Hello guys, welcome to fourth video of this section, Inversion of Control and Dependency Injection. Previously we have learned about view model and live data, their benefits and how to use them in Android. In this video, we will look into inversion of control and dependency injection. So let's start with inversion of control. Inversion of a control is a programming technique which, unlike traditional programming, where the flow of the business logic is determined by objects that are statically assigned to one another, invert it to create a flow which will be determined by behavior of dynamically assigned objects. There are various patterns using which this can be implemented, like service locator, factory pattern, parameterized constructor, and dependency injection. But in this video, we will only focus on dependency injection. Dependency injection uses object graph to create graph of all dependent objects and their dependencies. When such a dependent object is initiated, its all dependencies are satisfied by the framework with the help of the graph. And in dependency injection, we can implement it using Dagger. Dagger is a fast dependency injector for Android and Java. It's developed by open source by Square.ink. Now even Google is actually contributing to it. Dagger is built from bottom up from mobile platform. It statically analyzes all dependencies and injection. Since it's done at compile time, any failing dependency is detected at very early stage. It has negligible memory impact as it doesn't use reflection or annotation processing at runtime, unlike yours. So how it works? The basic structure of Dagger is object graph, a central dependency manager and injector. Developer need to create the graph manually to specify all the dependencies in application. Graph can be specified at application level or at smaller level like activity, service, fragment and view. And annotation we will be using for Dagger are at the module, provides, inject and many more. So let's start using all Dagger in our practical implementation. This is our latest project which we have developed in last video. Now we will add dependency injection in this project. To add Dagger, first you need to add two dependencies, com.google.dagger, Dagger 2.13 and annotation process for Dagger compiler 2.13. Use the latest version at the time you're watching this video. Okay, after adding dependencies, let's just build the structure for the Dagger. For the Dagger, first we need component, interface, call it main component, module, create a class called main module or project module, any one you can like. I'm going to call it project module. And third most important thing is application class, which handle our main dependency components. Main application, there you go. Now we will start with our main application. In our main application, extend it with application and private static main application instance, main application called main application. Also get the instance of main component. Now create a function public static main application get app. Whoever need get application context will call this function and we will return in this function main application instance. When we will set this main application instance, it will be in on create function. On create main application is equal to this, and we will create a new function called initialize component. There you go. And in this we need to initialize our main component, but as we haven't defined it yet, so we can't initialize it. Or in plus we need to inject our main component as well here. Dot inject, which we can't because we haven't defined it yet. So let's go to main component. In main component class, let's define its singleton. As we are using dagger, so we can use annotation singleton, and we have to define its component. So when we write add component, that's mean this main component class is a main component, and then in bracket we have to define its modules. In module, so far we have only one module, which is project module dot class. There you go. Now we need to define this project module class with annotation module, so it will know that this class is module. Now we can inject here different classes like void inject main application, void inject main view model. We have using two injector for main application and one view model. We will inject these two classes for now. Okay, now let's go back to your main application. As we have defined our main component class, so now we can initialize our main component as well here. So here first define main component dot inject this. We have injected our main application and our main component, as we have defined here, that we will inject our main application. Second, we will define our main component dot is equal to dagger main component, but to use dagger main component we need to rebuild our this class so that it will know that we have implemented dagger in this. So after rebuilding, we will set our component, and in component we will pass it to our module and other main component as well. Done. Now main component is equal to dagger main component dot builder dot project module. As you see here, project module, and now we will pass here new project module and use this dot build. There you go. Now we have initialized our components as well, and we will create one more function just here. Whenever whoever need main component, it will access our main application instance and call this function main component get main component, and from this function we will return main component. There you go. We are done with our main activity class. So now move to our main project. It didn't has any constructor yet, so ask him to create constructor. There you go. It has automatically created a constructor in our project module. So here in this project module we will get all our data using this. How? Let's create a dependency just to get a data from our project, like we are getting here in our project repository. It will still, our main view model, get the data from project repository, but our project repository will fetch this data like a web service from our project module. Let's move this logic cut and go to project module and call it @provides annotation. Provides mean it will provide singleton list project model. Provide project list and paste it here. Now to get this list, like this function, this list, we are going to create another instance here. Go back to project module, provide singleton project repository provides project repository what and return new project repository. And now what we are going to do, we are not going to declare our project repository in any other classes. Our project module always return our project repository whenever needed. But how will our project repository gonna know about this list? So we need this list here, list project list, call it project list, and then pass it to project model list, and then create this constructor. So now we have created a public function here, constructor, and it will concat project list, and this list we will update it according to our old model. But first let's go back to our module. Let's finish this one first. See what we have done here. We need this, our function need a list of project, so it will automatically known as we have defined a provider and it's returning the list of project. So we don't need to call this function anymore. It will automatically get this value from here, that it's return type this. It will automatically analyze it and after get the list from this function and then pass it to the project repository. Now what changes do we need to make in our project repository? First go to the project repository class. In our constructor now we are getting this list, so we will assign this list to our, here we will create a list of our function variable list project model called project listing or project model list, anything you like, and this dot project model list is equal to project model list. And there you go. Now move down. Now in here in this function we won't call this project list anymore. I will just pass project model list. We don't need it anymore. There you go. And in instance here, as is, we have already defined it singleton, but once we have made it dependency injector, we don't need it anymore. No singleton anymore. There you go. Don't need this one as well, because it will be handled by our dependency injector. So we don't need it anymore to make any kind of callings and this kind of stuff. Now go to our view model class. Now in our view model class we are going to inject just, we are going to use inject annotation at the inject project repository and project repository. Now it will automatically get it from our module that it has the provider notation. Whenever we inject it, it will automatically analyze that there is a provider, so it should provide here. So once we get it, then project, we don't need it anymore, this kind of long thing. We will be using our project repository, this project repository dot get project list. That's all. We don't need to do anything else anymore. Now our this function will work perfectly, and that's all for now. Since, why we use dagger? Since it's done at compile time, any failing dependency is detecting at very early stage. It has negligible memory impacts as it doesn't use reflection or annotation processing at runtime. So our next topic is going to be moving view controller logic into a presenter